Hi, my name's Kelly, and I'm a Wyzant chemistry tutor. Today, I'm going to help out with this question. Draw a series of diagrams that show the dissolution of solid ammonium chloride in water and identify all attractive forces at work. So first, we're going to talk about ammonium chloride. Ammonium chloride is an ionic compound comprised of ammonium, which has a positive charge, and chloride, which has a negative charge. So the intramolecular force that's holding it together is ionic. Water is a polar covalent compound. And what that means is that it is a covalent compound, so it's sharing electrons, but since it's polar, it's going to have a slightly more negative side and a slightly more positive side. And the reason why is because there's a difference in electronegativity. So that is going to be indicated by this delta En. The difference in electronegativity means that oxygen, since it's more electronegative, is going to have a slightly negative charge, whereas hydrogen, which is slightly less electronegative, is going to have a slightly positive charge. So we've got our ionic compound, and then it's going into water, which is a polar covalent compound. When that happens, what we see is the ammonium chloride is going to be attracted to water, but it's going to be different on either end. So the ammonium, which is that positive blue, which is the positive end of it, the blue dot here, that's going to be attracted to the oxygen, which is slightly negative. And it makes sense because positive and negative attract. Opposite charges always attract. Whereas on the chloride end of it, chloride is a negative ion. And so that's why it's going to be attracted to the hydrogen, because positive and negative attract. So on either end of the ammonium chloride, we're going to have an ion-dipole attraction. But the water molecules are lining up in opposite ways, depending on whether it's ammonium or whether it's chloride. So ammonium chloride is held together by an ionic bond. Eventually, if those intermolecular ion-dipole forces are stronger, it's going to cause that ionic compound to break apart. And then it's going to separate into separate ions. So that's when we have at the very bottom here, the positive ammonium ion surrounded by water molecules, but it's the oxygen end that's facing in because oxygen is slightly negative, which is going to be attracted to the positive ion. And then we have the chloride ion, which is a negative ion, an anion, and it's going to be attracted to the hydrogen part of the water molecules because hydrogen, that end of it, is going to be slightly positive. So once again, we have an ionic compound, ammonium chloride, and it's going to be interacting with water, a polar covalent compound. Once those ion-dipole forces are stronger than the ionic compound itself, it's going to break apart into separate ions, the ammonium ion and the chloride ion. Hopefully this video is helpful, and if you are interested in learning more with me, feel free to check out my Wyzant profile and schedule a tutoring session. Thanks!